Welcome to Monkey Physics IIT JEE NEET Foundations.
Yeah, let's start analyzing the situation for the object is thrown up with some velocity from the ground. So in the form of examples. Now when the object is thrown up with a velocity 40 meters per second, this is the ground. Now it's going up, isn't it? Now the question number 1, what they are asking. So what is the time taken to reach the ground again? So when it is thrown at t equivalent to 0, and what is the time taken to reach to the same level of thrown? Now question number 2, they are asking what is the velocity at t equivalent to 3 seconds. Now question number 3, what is the time of ascent? Now question number 4, now what is the velocity at t equivalent to 5 seconds. Now this is regarding the velocity only. Of course there may be where is a location after some time that comes under the category of displacement versus time analysis. Anyway, we do that in the later part. Now for the time being, these are the things and finally they are asking us question number 5, analyze velocity versus time changes. Analyze the velocity versus time changes. Now let's take here first I want to focus on the 5th question. Why? Because analyze velocity versus time means what is the velocity at any time. So we are talking about the velocity with respect to time only, right? So v is equivalent to u plus at. When we use this formula, v is equivalent to u minus gt, isn't it? I told you already, right? So initial velocity upward, acceleration due to gravity is downward. When these two are opposite to each other, we should substitute the negative sign here. And I told you the reason also, right? Yeah. Now v is equivalent to 40 minus 10t. Now first the clue we got here, this is nothing but the velocity as a function of time. And that is also one question we can frame like, so if the question is given when the object is thrown up with the velocity 40 meters per second from the ground, then what is its velocity as a function of time? Or express velocity as a function of time, and this is the answer. Now t and velocity we are taking at a particular time. So at t equivalent to 0, velocity is nothing but 40 because substitute 0 here. So 40 minus 0. Hope you are following. At t equivalent to 1 second, 40 minus 10, it's a 30 meters per second. Of course velocity in meters per second and t is in seconds. Now at t equivalent to 2, 20, 40 minus 20, 20. At t equivalent to 3, 40 minus 30, 10. At t equivalent to 4, 40 minus 40, it's a 0. At t equivalent to 5, 40 minus 10 into 5, 50, 40 minus 50, minus 10. At t equivalent to 6, 40 minus 60, it's a minus 20. At t equivalent to 7, it's a 40 minus 70, it's a minus 30. And at t equivalent to 8, 40 minus 80 is nothing but minus 40. Hope it's clear, right? Yeah. So first we need to focus on this particularly. Why? Because here the velocity is equivalent to 0, right? So velocity equivalent to 0 means this is the highest point. This is the highest point. Yeah. So this is the highest point. And at highest point velocity is equivalent to 0 and the time taken to reach the maximum height or highest point is nothing but t equivalent to 4 seconds. Now let us cross check with this. What is the time of ascent formula in the previous, according to previous case, u by g. So what is u given? 40 and upon 10. So time of ascent is equivalent to 4 seconds. That's what we got. Now here again total time of flight is nothing but 2u by g. So 2 into 40 by g. G is nothing but 10. I'm sorry. Yeah. 80 by 10 is nothing but 8 seconds, right? Now this is the time to reach the same level of throw or time taken to reach the ground again, right? Yeah. So one thing we can observe, while coming back to the same level of thrown or same level of projection, the velocity if you observe minus 40 meters per second. With what velocity we have thrown from the ground 40 meters per second. The moment when it reaches to the same level, minus 40. So what do we observe with this conclusion? Whatever the velocity you have thrown the object upward, now at the same level of projection when the object is coming back, it is coming back with the same magnitude of velocity but in opposite direction, downward. So that is what we should observe. And at the same time, when you try to understand this, now when the object is thrown up with 40 meters per second, so at t equivalent to 1, at t equivalent to 2, at t equivalent to 3, at t equivalent to 4, the velocity is, so what do we say here? Velocity, it's 30 meters per second, 20 meters per second, 10 meters per second and 0. Okay. So this is 1 second, 2 second, 3 second, 4 second. Now again while coming back, it's a falling down. So look at here, while coming back at t equivalent to 5, t equivalent to 3. So t equivalent to 5 minus 10 meters per second, t equivalent to 3, it's a 5 and 3, 10 and minus 1. So while going up it is 10, while coming back also it is 10. Now at t equivalent to 6, it's coming back with 20. Now at t equivalent to 7, it is coming back with 30, and at t equivalent to 8 second, so it reaches with the same magnitude of velocity 40 meters per second. Now you should observe these set of or a pair of times, okay, pair of times. What are those times? 3 and 5. So 3 and 5 magnitude of velocity is same, and 2 and 6. Now 2 and 6, look at here, magnitude of velocity is same, 2 and 6. Now 1 and 7 magnitude of velocity are same. Now at 0 and 8 magnitude of velocities are same. So that is an important observation we can have. So for the object thrown up with some velocity. Hope it's clear to you, right? Yeah.